Today's section, 5.2a, we'll be talking about trigonometric functions of real numbers. So first, we would like to restate stuff that we talked about in Chapter 6, so we're reminded of what's going on with some of these trig values. So remember, the domains of your trigonometric functions for sine and cosine are all reals. For tangent and secant, it's all reals except for when you have a pi over 2 plus pi to n, or pi n, meaning for any time that you go a half a pi across, so like 3 pi over 2, 5 pi over 2, or negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, and so on and so forth forever and ever in both directions, you're always going to have an undefined part where there's no value there, so the domain is restricted a little bit. Okay, so the n is only supposed to represent each, like to help you write out all the possibilities for infinite number. If you plugged in any n value or any integer, so like if you plugged in 10 into this function, you will get a x value that would be an undefined point for tangent and secant. Same thing for cotangent and cosecant. It's just that it happens at every pi. So starting at 0, and we don't put the plus 0, but you could if you wanted to. You could say plus 0 to that. But every pi, so at 0 pi, 1 pi, 2 pi, 3 pi, in both directions, you're always going to get an undefined line for cotangent and cosecant. Okay? So that's what those are saying. For your trig functions, the signs, so where they're positive and negative, are mapped out here, and we've talked about this before, locating them on the unit circle. So in quadrant 1, all functions are positive, none are negative. In the second quadrant, sine and cosecant are positive because your y value is above the x-axis. All the other ones are negative because they have a part of the x ratio, which is negative in that quadrant. Quadrant 3 is positive for tangent and cotangent. That's where y and x are both negative. So then, since you're dividing them to each other, that makes them positive. But since sine and cosine are separate, just them by themselves are negative functions. And in the fourth quadrant, cosine and secant are positive because you're on the positive side of the y-axis, on the right of the y-axis. So that means that all the other ones are negative because they have a piece of the y value, or y part of the point, of your terminal point in that quadrant. Okay? So here, let us find some of these values if you're given cosine of 4 pi over 3. So here now you could do it many different ways. We can look at the unit circle. We can use our reference numbers to do these. Let's use our unit circle here because I'm sure you're pretty good with the unit circle now. And actually, let's make that a little bit smaller. Okay, so 4 pi over 3 is the third, or the pi over 3 value of the third quadrant, so it's located right there. Now the point for that, since it's the 60 degree, or the pi over 3 value, remember it's 1/2 square root of 3 over 2. So then here, cosine, remember, is negative in this part, so that's your x value, because if I reflect over, the 2 pi over 3 value for that one is negative 1/2, comma, square root of 3 over 2. So that means that this one's negative 1/2, comma, square root of 3, or negative square root of 3 over 2, because it's both negative for cosine and sine. But since I'm just looking for the cosine of this, it would be negative 1/2 for our cosine of 4 pi over 3. For tangent, it's negative pi over 6, so that would be in the fourth quadrant if I added 2 pi to this to make it in between 0 and 2 pi. That would give me 12, that would be 6, so that would give me 11 pi over 6, so it's the same thing, which is right there. Remember, that is the 30, or the pi over 6 of the fourth quadrant. So in the first quadrant, that point is square root of 3 over 2 comma 1/2. So if you flipped it over, it would be square root of 3 over 2 comma negative 1/2 because your y value is negative. Now since I'm looking for tangent, remember sine over cosine for this angle. Okay, so then I take negative 1/2 divided by a positive square root of 3 over 2. I multiply by the reciprocal. The 2's cancel out. And I can leave it as negative square root of 3, or sorry, negative 1 over square root of 3. Or you can rationalize and make that negative square root of 3 over 3. Okay? Let's use a different color for this next one. So if I have sine of 21 pi over 4, it might be easier if I got this in between 0 and 2 pi. So let's take 21 pi over 4 and subtract 2 pi from that. Same thing as 8 pi over 4. That gives me 13 pi over 4. Okay? Still not in between, so let's do it again. So subtract another 2 pi or 8 pi over 4. It gives me 5 pi over 4. Okay? So now, sine of 5 pi over 4, using my unit circle here, that would be in the third quadrant. That's the 45 of that one. So remember, the value in the first quadrant is square root of 2 over 2. Square root of 2 over 2. So for that point, since you're in the third, both of them are going to be negative. So now since I'm just looking for sine, I want the y value, so it's negative square root of 2 over 2. Okay? And those would be my answers for that. Here, for the next one, I just want you to remember that cosecant of t is equal to 1 over sine of t. Secant of t is the same thing as 1 over cosine of t, and cotangent of t is equal to 1 over tangent of t. Just remember that those are reciprocals of each other. So like for example 2, we're going to find each value to the nearest 2 decimals. Notice how they're not on the unit circle, so we're going to have to use our calculator. So remember, these are radian measurements. So to get the values that we want, we need to make sure our calculators are in radians before we move forward. But now if I plug in sine and type in 3.1 and parentheses, that gets me 0.04 and 1, but the 1 is just rounds to 4, or rounds down, so I get 0.04 for that one. Then doing cosine of 0.9, plug that in. It gets me 0.62 rounded to the hundredth. And then cotangent of 35. Now cotangent, remember, is 1 over tangent. So this is the same thing as saying 1 over tangent of 35. So let's take 1 divided by tangent 35, close those parentheses. That gets me 2.11 for my ratio. Okay? Moving on to the next one. Here, now I want to talk about even and odd properties. So if you remember back to chapter 2, we were talking about functions, and they were odd functions and even functions. Ones that were even functions were symmetric with the y-axis. So if you plugged in a negative value in for x, you were going to get the same exact function that you started with before you plugged it in. And odd functions, when you plugged in a negative function, it changed all the signs for your trig functions to the opposite. So like if something was negative, it went to positive. If it was positive, it was negative. So here, the odd and even function thing works for trig functions as well. So odd functions are listed right here. So sine, cosecant, tangent, and cotangent are all odd functions. So when I plug in a negative angle or radian measurement in for the trig functions, then I get a negative ratio for those trig functions. Even functions are just cosine and secant. So when I plug in a negative radian or angle measurement, then I get the same exact trig function that I started with, which is cosine of t and secant of t. Okay? So example 3 wants us to use these to help us out. So sine is an odd function, and so since I'm plugging in a negative radian measurement, this is the same thing as saying negative sine of pi over 3. Okay? And if you go back to your unit circle, pi over 3 is the same thing as 60. And so the point there is 1/2 comma square root of 3 over 2. So then, since I'm looking for sine, it's the square root of 3 over 2. But I just take a negative and tack it onto my ratio. So it's like multiplying a -1 times the ratio that you're doing. Okay, letter B. So cosine of negative 3 pi over 4 is the same thing as cosine of 3 pi over 4. So we can drop the negative because it's an even function. So now, if I want to look at my unit circle, 3 pi over 4 lands over here in the second quadrant. Now if you're, so then my point is square root of 2 over 2, comma square root of 2 over 2, and then I'm looking for the cosine, so it's just square root of 2 over 2. Even though negative 3 pi over 4 would be right there, because they have the same x position vertically. Okay? So then cotangent. Here, remember cotangent, when it's negative, it's an odd function for your angle, so then same thing as saying negative cotangent of pi over 6. Now here you can go different ways with it. You can say that it's a negative do negative 1 over tangent of pi over 6, or you could do negative sine of pi over 6 over cosine of pi over, cosine of pi over 6 over sine of pi over 6. Let's do it that way. So here, cosine of pi over 6 divided by sine of pi over 6. Okay, so at pi over 6, it's the 30 of that one, so square root of 3 over 2, comma 1/2. So then now, cosine is square root of 3 over 2 divided by 1/2. And then multiply by the reciprocal. 2's cancel out, so I get the negative square root of 3. Okay? And so those would be my answers. And here's a little picture for you. Looks like a guy is trying to save people from a fire. Okay? Have fun.